Hello, you absolute legends. We're going to draw some Lewis dot structures of small molecules following these 3 steps. Now, you may see examples that have more than 3 steps, kind of with more rules and special exceptions and things like that, and those are fine. These 3 steps are going to get through most pictures, most small molecules in Gen Chem. Some of those extra steps are valuable when you get to more advanced chemistry. Now, the key with these 3 steps in here is that you are going to cycle through these 3 steps or loop through them until step 1 and step 3 are both valid or fulfilled. So let's get started. We're going to do BF4 with a -1 charge. So to get our total electron count, we're going to consider the 5 atoms that are present and also the charge of the molecule. To understand how many valence electrons that each atom is going to bring to the table is we're going to find that atom on the periodic table. This is boron's location on the periodic table. Take a moment and convince yourself of that. Now, boron has 5 electrons total in its neutral state, and only 3 of them are used for bonding in the valence shell. So boron brings 3 electrons to the bonding buffet. Now, fluorine has 9 total electrons, but its valence shell contains only 7. So to the bonding buffet, fluorine brings 7. I have 4 of them, so 14, 28. So all my fluorines are bringing 28 total in here. Now I have a -1 charge in here. That means that it must have acquired 1 electron. That is how things acquire a negative charge in the universe. They gain or steal 1 electron. So put a 1 in there. So now if I add this together, I get 32 electrons. Okay? That number is important when I draw my Lewis dot structure. You can't have any more or any less than 32 electrons. When you're doing these problems, especially early, you should be getting even numbers for your counts. If you're getting odd numbers, double check the charges or your counts off the periodic table here. So 32 electrons, no more, no less. You're going to start with 1 bond when you draw your first edit or your first guess of this Lewis dot structure. Now we have 5 atoms, and usually these small molecules kind of follow the template of a compass rose that you see on a map. There's an element in the middle, and then on the north, east, south, west points, there are elements that surround it there. Now there's 2 things to think about with deciding which element should be in the center and which elements are going to be out here on the edges. The first thing to keep in mind is that usually the grammar, this element listed first, is trying to tell the reader it's in the center. It's in the middle, right here. Another thing that might come up on other people's rules, Lewis dot structures, is that usually the element with the least electronegative value usually ends up in the center. It is going to bond the most amount of times. Think about it. This element in the middle has to bond at least 4 times to be able to connect to these 4 things here. So let's start with that. The first element is starting in the center here. This sounds like a lot, but as you do more, these really become very habitual and reflexive. So we have the boron in the center, and we're going to make 1 bond to the fluorines on the to each of these 4 fluorines on the perimeter. So I've made only 1 bond between each of these atoms here, because my first guess is going to be the simplest guess, just 1 bond. So now I'm going to check octets. I'm going to start with that element at the north, fluorine. It needs 6 more. So now it has an octet. Now I'm going to go to the east. It now has an octet. On the southern edge, it has an octet there. And then on the western edge, excuse me, this fluorine has an octet. And I cannot forget the guy in the middle here. Try to cover up. Oh, he's already set. By making those 1 bonds at the beginning right there, he already has, oops, excuse me, it's kind of reusing index cards. He already has 8 in the middle right there. 1, 2, 3, 4, 5, 6, 7, 8. If you think I am double counting these electrons, you're absolutely right. Because these are covalent compounds with a sharing of electrons, the shared electrons can be double counted. So everybody has an octet. I'm going to cycle back up to step 1 because I'm only allowed to have 32 dots, 32 electrons. I need to get my best finger out. I got 32 electrons in here. The cherry on top is this little bracket here to tell the reader that there's a -1 charge. Thank you.